Hello Pre-Calc, this is Mrs. Mueller. I am going to go through every single problem from the Chapter 5 Part 2 review. So watch it all, watch just the ones that you need. It'll be a long one because I'm going to go through all the problems. So first set of questions, it says, in what quadrant is each angle in? Name a positive and negative angle that is coterminal with the given angle. Name all the angles that are coterminal with the given angle. Find the reference angle. Okay, so I am going to use the unit circle on most of these problems, so I would suggest either having one up on your screen or having a couple printed out ones or just one printed out one that you can reference as we go through these and write on and make it your own. So first one here is 130 degrees. So 130 degrees isn't exactly on the unit circle, but here's 0 and here's 90, and we need to keep going 40 more past that. So it's going to end up being, I don't know, somewhere in here. Okay. And that right there, that thing we drew, that's called the terminal side. So just to kind of give you some vocabulary there, that's called the terminal side. This side over here is called our initial side. So you can see we have an obtuse angle. It's about 130 degrees. Okay. So what quadrant did we land in? This is the first quadrant, second quadrant, third quadrant, and fourth quadrant, so we landed in quadrant 2. Okay, to get a positive, another positive coterminal angle, we just want to take 130 degrees and add 360 degrees to it. So 130 plus 360 is 490 degrees. Okay, to get a negative version, we can take 130 degrees and subtract 360 degrees from it. And then we will see that just by doing that once, we end up at negative 230 degrees. And there are infinitely many answers there. You could, for positive ones, you can keep adding 360 to get to a new coterminal angle. For negatives, you could keep subtracting until you get to another one. Okay? For all coterminal angles are 130. I like the way that looks. 130 is what we're starting with, plus 360 degrees K. All right, and K stands for either positive or negative revolutions around your circle. How many times are you going to go an additional 360 degrees? Okay, and then reference angle. I think reference angle is one place where students tend to get a little stuck or end up with the wrong answer somehow. For reference angles, you always want to start with a horizontal line. So I'm going to draw in a horizontal line, and then you are going to take your terminal side, and you're going to drop that kind of down like that. Well, you don't even need that vertical line really, but your reference angle is always between a horizontal line and your terminal side. So it's that angle right there. So basically just ask yourself, okay, where are we here? We're at 180 degrees here. And where are we up here? We're at 130 degrees. What's the difference there? How far is it between 180 degrees and 130 degrees? It's 50 degrees. And your reference angles are always positive. Okay, always, always, always positive. All right, moving on to number 2. So same directions, just a different problem. So negative 215 degrees. For that one, I don't really like working backwards if I can avoid it. So right away, I'm going to take negative 250 and I'm going to add 360 to it. I'm going to find a coterminal angle that's a little bit easier to work with. So that's going to give me 145 degrees. I like that. I like that a little bit better. So now 145 degrees is going to be right in here somewhere. So it ends up actually being pretty similar to our first problem. Okay, so there's our angle. That's our 145 degree angle. So we once again end up in the second quadrant. We kind of already did the work for a positive one. We're now at 145 degrees. For a negative one, take your negative, oh, this should have been negative 215. Fix that. Negative 215 minus 360. And that is going to give you negative 575. And then to get the expression for all of them, it's just negative 215 degrees plus 360 degrees. Okay, that one's pretty simple. And then your reference angle, once again, make sure you are starting with a horizontal line up to your terminal side. So it's this angle here. So basically, once again, how far is it from 180, or what's the difference between 180 and 145? Difference between 180 and 145 is 35 degrees. Okay, move on to the next set of problems, which we're evaluating each of these. So I'm going to use the unit circle as much as I possibly can on these. So on each problem, I'm going to pull up a new unit circle and show my work on that. When you guys are doing this on your paper, you should just sketch them the same way you would on the test. So kind of just take the pieces of the unit circle, or however way you're going to do it, and sketch it so that I can see that you know what you're doing when you take the test. So sine of 210. Before we do these, let me just remind you, using the unit circle, sine is your y value, cosine is your x value, tangent is y over x, cosecant is 1 over y, secant is 1 over x, and cotangent is the reciprocal. All of these are reciprocals, but the reciprocal of y over x, which would be x over y. So if you don't already have that written down somewhere, that would definitely be helpful. Okay, so now sine of 210, it's super duper simple using the unit circle. All we have to do is find 210 degrees and pick out, because it's sine, pick out the y value, negative 1/2. Done. Cosine of 300. This is number 4, so moving down on your paper. Cosine of 300, all we have to do is find 300 degrees. It's right here. Cosine is your x value, 1/2. Done. Number 5, tangent of 315. So this one, tangents are always a little bit more work. So find 315 degrees. It's right here. Here's your x, here's your y. Tangent is y over x. So negative square root of 2 over 2 divided by positive square root of 2 over 2. Well, those are the exact same thing, except the top is positive and the top is negative. So anytime you take something and divide it by itself, you get the exact same thing out, or you get out 1. So 7 divided by 7 is 1. 9 divided by 9 is 1. Negative 9 divided by 9 would be negative 1. So in this case, basically those guys canceled out, and you're left with negative 1. Cosine of 270, so find 270. That's right here. Cosine is your x value, so your answer is 0. Number 7, this one's a little bit more work. Cotangent. So remember, cotangent is x over y. So first we have to find 240. There's our x, there's our y. So we have negative 1/2 divided by negative square root of 3 over 2. Okay, remember, dividing is the same as multiplying by the reciprocal. So negative 1/2 times negative 2 over the square root of 3. Okay, so a couple things happen here. Negative times a negative is a positive, so those can go away. Now you have a 2 on top and a 2 on bottom. They can go away. And you're left with 1 over the square root of 3. So I'm totally fine if you leave your answer that way. That's good. Or if you would rather not leave a rational number in the denominator, remember we can rationalize the denominator by multiplying by square root of 3 over square root of 3. And you're going to end up with square root of 3 over 3. Either one of those is totally acceptable on the test. Number 8, secant. So just a reminder there, secant is the reciprocal of cosine. So cosine is your x value. Secant is 1 over your x value. So find 225 right there. Find your x value. It's right there. And your answer is going to be 1 over negative square root of 2 over 2. Okay, so that's one way to think about it, and we can just do it the same way that we've been doing it. Dividing is the same as multiplying by the reciprocal. So 1 times the reciprocal, 2 over the square root of 2. I'm going to get a negative in there. And obviously 1 times anything is that something. Or once you kind of get the hang of it, you'll just kind of realize that secant is the reciprocal of your x value. So if it's already written as a fraction, just flip-flop it right off the bat. So you end up with negative 2 over the square root of 2. Or, once again, you can rationalize that. And this one ends up being kind of different here. So if we rationalize this, I like the idea of rationalizing this one especially. So what happens is you end up with negative 2 times the square root of 2 on top and 2 on the bottom. And then you can see that those 2's cancel. So you actually just end up with negative square root of 2, which actually looks a lot nicer and simpler than the other one. So yeah, I would suggest rationalizing the denominator whenever you can. Number 9, cosecant. So cosecant is the reciprocal of sine. So it's 1 over your y value. And it's 90 degrees. So find 90 degrees. Find your y value, which is 1. And then the reciprocal of 1. 1 divided by 1 is all you're doing. Your y value is 1. 1 divided by 1 is 1. So that one's pretty simple. Number 10, sine of 180. Sine is your y value. So here's 180. There's your y value. It's just 0. Number 11, secant of 405. Okay, a couple things I would do here. First of all, remember that secant is the reciprocal of cosine. Cosine is your x value, so it's 1 over your x value. The other thing I would do, I don't love 405. I would subtract 360 from it. When you do that, you end up with 45 degrees. I think that makes it, that's easier. That's right on our unit circle. It's just a coterminal angle. And then we're looking for 1 over x. Okay, or you can just do the reciprocal. I'm going to do it that way this time. The reciprocal of square root of 2 over 2, just flip-flop them. So 2 over the square root of 2. And then that's another one where I think it really helps it look better if we rationalize the denominator. So multiply straight across the top, straight across the bottom. Square root of 2 times square root of 2 is just 2. Now you have a factor of 2 on top and bottom, so they can go away. And your final answer is the square root of 2. Number 12, tangent of negative 120. Again, I don't love that. I would add 360 to it. Anytime I have a negative or something that's bigger than 360, I would find that coterminal angle. And you're going to end up with 240 degrees, which is on our unit circle. It's right here. Tangent is y over x. So in our case, it is negative square root of 3 over 2 over negative 1/2. Okay. Division is the same as multiplying by the reciprocal. Negatives cancel. Negative times a negative is a positive. Factor of 2 on top, factor of 2 on bottom. That 1 doesn't really do anything for us, so we are just left with the square root of 3 for our answer. Okay, so hopefully that helps. In my opinion, those problems are really pretty easy if you're using the unit circle, especially if you have, you know what that sine is the y and cosine is the x, and so on. Okay, these guys, starting with number 13, so the back side of the second page, I guess. These ones start to get a little bit more tricky. Again, I'll use the unit circle when I can. Can't use it on all of these, but there are some where we can use them. So just a couple things before we get started with these. You're gonna have 2 answers for some of these. All of them, I guess. So from 13 to 20, we'll have 2 answers. So just be careful with that. You can, I think it is helpful to kind of remember this all students take calculus thing. So that's where your things are positive. So in this quadrant, everything is positive. Sine, cosine, and tangent. Sine, cosine, tangent, all positive. Over here, just your sine is positive. Down here, just your tangent is positive. And down here, just your cosine is positive. So I think that does help a little bit. So if we are looking for arctan of 1, remember that's exactly the same as tan inverse of 1. Those mean the same thing. It doesn't matter which way you write it. Get used to seeing both of them because you'll see it both ways. Okay, so basically we want to figure out where tangent, which is y over x, where is that equal to 1? So basically, where are x and y equal? We want x and y to be the exact same thing. Because remember, something divided by itself is what's going to give you 1. So tangent is positive down here. That's good because we want it to be positive 1. Tangent is also positive up here. So basically, we are only looking in quadrants 1 and 3 for our answers. Okay? So pretty simple from there, I think. Here's your x, here's your y. They're exactly the same, so one of your answers is 45 degrees. And then down here at 225, your x and your y are exactly the same. So those are your two answers, 45 degrees and 225 degrees. Next one, inverse cosine of negative 1/2. So it is definitely not going to be in the first quadrant because everything's positive up there. And then all students take calculus, so cosine is going to be positive down here. So it's also not going to be down there. So we are looking for our x value to be negative 1/2. We're going to find that in two places. We're going to find it right here, and we're going to find it right here. So our two answers are 120 degrees and 240 degrees. That one's done. Next one. Arc cosine of square root of 2 over 2. So just kind of get used to seeing numbers that show up on the unit circle. Square root of 2 over 2 is one that definitely pops up on our unit circle. So we're looking for our y value to be square root of 2 over 2. It's going to happen in two places. And I'm not even going to do the whole all students take calculus thing. I'm just going to remember that y values are positive up here. So square root of 2 over 2 for y value happens there. Square root of 2 over 2 for y value happens there. So our two answers are 45 degrees and 135 degrees. That one's done. And then number 16 here, arc cosecant or inverse cosecant, negative 2. So this is one where I don't know, it might be, well, we can use it, using the unit circle. So just remember, cosecant is the inverse of sine. So we are looking basically for the reciprocal of your y value to be equal to negative 2. So just think about that in your head. What is the reciprocal of negative 2? Well, negative 2 is the same as negative 2 over 1. Flip-flop that, and you end up with negative 1 over 2. So you are looking for, on the unit circle, where is your y value, negative 1/2? It's going to happen in two places, right here and right here. So your two answers are 210 and 330. Number 17, inverse sine. So we're kind of going in a weird place on our paper here. Now we're in the upper right-hand corner. This one we're actually only going to have one answer, and we'll see why I lied to you when I said they all had two. We're looking for where our y value is negative 1, and that only happens right here in this one location. So our answer there is just 270. There aren't any other answers. So if you only end up with one answer, it's because your answer is one of these kind of easy ones, one of these ones that ends up on the axes. Next one, arctan of negative root 3. Okay, so this one, tangent is y over x. These ones always take a little bit more thinking. So we want, first of all, we want it to be negative. We want negative square root of 3. So think about where your tangents are negative. So not up here. Everything's positive up here. That's our all. up here, all students, this is where sine is positive, so it's not going to be there. Sorry, it is going to be there because only sine is positive. Down here is where tangent is positive, so not down here. And then down here in quadrant 4, cosine is positive, so it can be down there. Tangent would be negative in quadrant 2 and quadrant 4. Okay, so now we just have to remember we're doing y over x, and we want it to be square root of 3 over 3. Well, it's not going to be, or sorry, just negative square root of 3. So it's not going to be that one because those are square roots of 2, and it's not going to be that one. So basically, just kind of test one of these. So let's try this one. So there's y, there's x. So if I do 1/2, I'm going to jump right to multiplying by the reciprocal. Instead of dividing by the x, I'm going to multiply by 2 over negative square root of 3. Okay? And you end up with 1 over negative root 3. That's not what we want. We want it to just be negative square root of 3. So let's just try this one really quick. So we want to do y divided by x, so negative square root of 3 over 2. I'm going to jump straight to multiplying by the reciprocal. Okay, so here our 2's cancel. We got a factor 2 on top and bottom. We have our negative here that we can use. We have the square root of 3, and then over 1, but we don't really need that. Okay, so that is one of the ones that we want. Okay, so one of our answers, this is in the way now, one of our answers is 120 degrees. Our other answer is going to be down in quadrant 4, and basically we want that exact same order. We want negative 1/2, or I guess positive 1/2 for our x value, and negative root 3 over 2 for our y value. That's gonna give us our same answer. So our other one there is 300. So the only thing that's different about the ordered pair at 300 is your negative is in the other location. Your negative is with the y instead of with the x. All right, moving on. Sine inverse of negative root 3 over 2. So we are looking for our y value to be negative root 3 over 2. Y values are going to be negative down here. And there's one. And there's one. So 240 and 300. Number 20. We're looking for cosine to be 1/2. Cosine is your x values. So positive x values are going to be over here. So we're going to have one right here, positive 1/2, and positive 1/2. Two answers are 60 and 300. All right, now we're moving on to kind of a different type of question. We can't use the unit circle quite as much on these ones. Actually, not really at all on any of the ones on the review here. So first one, number 21, is super simple because cosine and inverse cosine are inverses. So they kind of just cancel each other off, and you end up with 3/5 as an answer. Done. Next one, we definitely get a little bit more difficult here. So the directions aren't great on here. I think all of these we are assuming are in the first quadrant. And I think the directions on the test are going to remind you that all of these are in quadrant 1. All right, so the rest of these we're probably going to have to draw a little picture. So start on the inside. So start with basically you're drawing a picture where sine is 2/7. And you don't have to be super picky at your pictures. Try to make it like somewhat reasonable. Okay, so sine is opposite over hypotenuse. So here's our little angle. We're in the first quadrant each time. Opposite side is 2, so I was going to make a right triangle. Hypotenuse is 7, okay? So that's done. We're done with that part. We don't have to worry about it anymore. We did it, okay? Now we're looking for tangent of that triangle. Well, tangent is what? Oh, well, opposite over adjacent. We have our opposite side. We do not yet have our adjacent side. So we need to find it. Well, anytime you have two sides of a right triangle, you can always find the third one using the Pythagorean theorem. Okay? So your C is always your hypotenuse, and then your legs are A and B. So I'm gonna call this, I'll just call it A for adjacent, that's fine. So A squared plus 2 squared equals 7 squared. Just make sure your hypotenuse is always the one that's by itself. And then just solve this. Take the square root of both sides, and you end up with A equals the square root of 45. And you don't need to do anything else with that. You could simplify it, but we're not worrying about that right now in this unit. We're just going to leave them all as they are. You could pull out a 9 from there. 45 is what, 5 times 9. Square root of 9 is 3, but we'll leave that for another time. Okay? So now all you have to do is remember that tangent is opposite over adjacent, so 2 over the square root of 45. And that's fine. You can leave it like that. You can rationalize it. I'm not going to rationalize any of these. I'm just going to keep going. Okay, next one. We are just starting with this part here, and we are always doing these up in the first quadrant. So sine is 7 over 10. So let's see, opposite, we want to be about 7 and 10. So we want those to be a little bit closer in length. So opposite and hypotenuse. Okay, and we're looking for secant. So remember, secant is the reciprocal of cosine. Cosine is A over H, so secant is H over A. So we have our H, so we already know our top number is 10. We don't know what the bottom number is yet. We don't know what our adjacent side is. So it's just like the one that we just did, only different numbers, pretty much. So A squared plus 7 squared equals 10 squared. And A ends up being the square root of 51. So really, these really aren't that hard. As long as you can do the Pythagorean theorem and know what sine, cosine, tangent, cosecant, secant, cotangent are, you're fine. All right, number 24, super easy. Love it when that happens. Tangent, arctangent, those are inverses of one another. So your answer is just 4/3. 25, we have the cotangent of cosine. So start out, we're going in the first quadrant. Cosine is adjacent and hypotenuse. So we want our adjacent to be kind of small, our hypotenuse to be kind of long, something like that. So 5 and 13. I'll label these. And we're going to end up finding cotangent. Cotangent is adjacent over opposite. So we need to find our opposite side. So Pythagorean theorem, 5 squared plus, I don't want to use the O because it looks like a 0. So I'll call it x. X squared equals 13 squared. No, it ends up being nice. Maybe that's one you already knew. 5, 12, 13, right triangle. Alright, so just A over O. A is 5. O is 12. You're done. Number 26. Start with finding sine, or drawing a triangle sine, where you have opposite of 3 and hypotenuse of 5. Something like that. 5. Opposite is 3. We're looking for cosecant. Cosecant is the reciprocal of sine. Yeah, so that's nice. We don't really have to do any more work. So we are looking for H over O. We already have H is 5 and O is 3. So we don't have to do any Pythagorean theorem there. We could if we wanted to, but we don't need the adjacent for anything anyway, so let's not waste our time. Moving on, we got 2 more of these. 27. So secant, and we want 7/4. So just a reminder, secant is the reciprocal of cosine. So if cosine is a over h, then secant would be h over a. So draw yourself a picture where the hypotenuse is 7 and the adjacent side, we're always working off of this angle, adjacent side is 4. Hypotenuse, adjacent. We're looking for sine, which is O over H, so we do need O. I'm going to call it X. So 4 squared plus X squared equals 7 squared. Is that 33? Alright, and then O over H, so O is square root of 33, and H is 7. That one's done. And then one more, cosine of arc cotangent. So cotangent is the reciprocal of tangent, so not OA, but AO. Yep. We haven't had one quite like this yet. So this time we don't know what the hypotenuse is. But we do know the adjacent side is 5 and the opposite side is 6. And since we're finding cosine, adjacent over hypotenuse, we definitely need our hypotenuse. So this is our C. So a squared plus b squared equals c squared. Oops. Is that 61? So our hypotenuse ends up being the square root of 61. So adjacent over hypotenuse, 5 over square root of 61. Okay, moving on. These ones, more Pythagorean theorem. We end up with Pythagorean theorem basically from here on out. So we want to just kind of guesstimate where the point 46 would be. So there's your x, there's your y. So over 4 and up 6. It's not a very good picture, but it's fine. We'll go with it. So in these guys, we're not going to have the hypotenuse, but we are going to know that we went over 4 and we went up 6. So we have to find our hypotenuse to begin with. So a little Pythagorean theorem, 4 squared plus 6 squared equals c squared. It's going to end up being 52. So c is the square root of 52. And then we're supposed to list all 6 trig ratios. So sine, cosine, tangent, reciprocal of sine, that's our cosecant, our secant, and our cotangent. Alright, so sine, label these, opposite, adjacent. Sine is 6 over root 52. Cosecant, we just flip them. We're not going to rationalize any of these denominators. Cosine, 4 over root 52. Secant, flip them. And then tangent, 6 over 4. Yes, I know that can be reduced. You could reduce it if you want to 3/2, or just keep it as 6/4. We're not doing much reducing here. And 4/6. Number 30. -2, is right here. Okay. So this is one where I would kind of just think about the unit circle here to do these ones. Technically, you're not exactly correct if you just use -2. So I would think about on the unit circle here, this is your 180 degrees, and it's actually at -1, 0. So the things that worked with drawing the triangles and and these ratios here, they're all correct because they're all ratios. And we created a triangle, and it doesn't matter how big or small the triangle is, our ratios are still gonna work just fine. But if you do land on one of the axes, you can't just use the -2. So think about what that angle is on the unit circle, and that angle is 180 degrees. And on the unit circle, that's at -1, 0. So I would use those numbers. So sine, cosine, tangent, secant, secant, cotangent. So sine is your y value. So sine is 0. Cosine is your x value. Tangent, y over x. 0 divided by -1 is just 0. Cosecant is 1 over your y value. 1 divided by 0. Uh-oh, that's a problem. That one is undefined. Secant. Secant is 1 over cosine. So 1 over your x value. 1 over -1 is -1. That works. Cotangent would be, so tan is y over x. Cotangent is x over y. If you try that, you end up with -1 over 0, which is undefined. So that one's also undefined. And then 31. -3, 4. So left 3 and down 4. Something like that. So oops, up 4. Whoops. Try again. Leaving that mistake on there just to show you it's okay to make mistakes. Not perfect. Alright, so that one's -3. That one is 4. To find the hypotenuse, we just know that one. 3, 4, 5. That's a pretty common right triangle, so I'm not going to do any Pythagorean theorem there. Okay? Here's your angle. This is opposite. This is adjacent. This is hypotenuse. Sine, cosine, tangent, secant, secant, cotangent. All right, we should be able to fly through these. Sine is 4 over 5. Cosecant, flip them. Cosine, -3 over 5. Make sure you get that negative in there. That's important. Secant, -5/3. Tangent would be O over A, so 4 over -3. Cotangent, flip it. And that one should be good. I'm just double checking. I went faster that one. I want to make sure I got them all right. I think so. Okay. Last set of problems here. Given the trig ratio and the quadrant the angle is in, find the other trig ratios. Okay. So they are telling us we are in quadrant 2. So when I'm drawing my picture, I'm just going to kind of highlight quadrant 2, and they're telling us that sine is 5/9. So opposite and hypotenuse. So opposite is going to be about 5, and hypotenuse is going to be about 9. Okay, so we know that we went to the left here, so that's going to be a negative. So I put that in right away before I forget. And we have to figure out what that one is. So 5 squared plus, that's going to be our adjacent side, squared is 9 squared. (81 minus 25 is 56. So -√56 over here. Okay? So we are supposed to find, I'm just going to, let's see. Yeah, I'm going to write them all down just because I'm in the habit. So sine, cosine, tangent. So sine we already knew was 5/9. Cosecant, 9/5. Cosine would be -√56 over 9. Flip it around. -9 over √56. And then tangent, this is our adjacent. I'm going to label that O over A. So 5 over -√56. And then root 56 over 5. Would be our last one there. Number 33. 33. Yes, that is right. So we are in quadrant 4. So we are going to be down here. And tangent is negative 5/9. So opposite and adjacent. Okay. So I'm just gonna, I don't know exactly what this is gonna look like. But opposite side. So you gotta think here, which one is gonna be negative? Sorry, I messed up. Now I gotta a re-recording. But I fractured erased the board. Okay, so we gotta think about which one's gonna be negative here. So we are down in, let me make this like this again. I messed up for the second time. Alright, I'm leaving all this stuff up though. Woo! Okay. I'm not gonna mess up this time. This is when you know the worksheet has just gotten too long. Okay, we're over here. Alright. Opposite side is 5. That was my problem. I kept writing it in the wrong spot. Opposite is 5. Adjacent is 9. We're going to think about which one's positive and which one's negative. That's why they tell you which quadrant it's in. So in this quadrant, in the fourth quadrant, you are going in the positive x direction. So x is positive. But you are going down over here. So you're in the negative y direction. And I'm going to spare you the Pythagorean theorem. So this is adjacent and opposite and hypotenuse. It ends up being the square root of 106. All right, I'm going to fill these in and call it a day. You guys can, I think I gave you enough information here. You can figure out the last two problems. So sine is negative 5 over square root of 110. We're not going to worry about that. Let's see. Reciprocal of that would be square root of 110 over negative 5. Doesn't matter what that negative is. Cosine is 9 over root 110. It's 106. I really need to just be done with this. Should have quit 2 problems ago. Alright, this guy's going to be square root of 106 over 9. Tangent. That one I should be able to get right. We already have it. Negative 5/9. Cotangent. Flip-flop it. Okay, I'm done. I quit. It's been 43 minutes almost. So let me or your teacher know if you have any other questions on this stuff, and we can help you out.